You know, we trust AI with so much these days, right? From what movie to watch next to way more serious things like our financial futures. But what if the code that we think is purely logical is actually making biased decisions? That's what we're going to dig into today.
So let's just start with the big one. Can a machine actually be biased? I mean, it sounds like a contradiction, right? Computers just run on math and logic. But the answer, well, it's way more complicated than you might think. And it really gets to the core of both the incredible promise and the serious peril of modern AI. So to really get to the bottom of this, we've got to start with the basics. How in the world do these machines get so smart in the first place? It all comes down to this idea called machine learning. And here's the most important thing to get. Programmers aren't sitting there writing code for every single possible outcome. Instead, they build these algorithms that learn and get better all by themselves, just by chewing through massive, and I mean massive amounts of data. It's like learning from experience, but on a scale we can barely imagine.
A super popular way to do this is with something called a neural network, and it's so cool because it's actually inspired by our own brains. You can see here how an input, say a picture, gets processed through all these connected, hidden layers, kind of like how the neurons in our own brains fire off messages, until it produces an output, like, yep, that's a cat.
Okay, so how does it actually learn? Well, it's all about the training. You feed it millions of examples that have already been labeled by humans. By looking at thousands of pictures labeled airplane and thousands labeled bird, the network starts to build its own internal rules, its own understanding of the world, an understanding based entirely on the data we show it.
And this right here is the absolute heart of the problem. If you remember one thing, make it this. An algorithm is only as smart and only as unbiased as the data we train it on. Think about it. The machine has no common sense, no built-in idea of what's fair or right. It only knows the world that we've presented to it in that data.
So, what happens when the data we feed these machines is a reflection of our own messy, unequal world? Well, the consequences can be huge. Let's look at some real-life examples. Let's start with a really high-stakes example, the criminal justice system. Courts are actually using algorithms now to create a risk score. It's a single number that predicts how likely someone is to commit another crime. And that one number can literally change someone's life, influencing bail, parole, even how long their sentence is. The stakes just don't get much higher.
So back in 2016, ProPublica did this deep dive, and what they found was pretty shocking. Just look at this table. The algorithm they studied was almost twice as likely to wrongly label black defendants as being high risk when they actually didn't reoffend. And on the flip side, it was more likely to incorrectly label white defendants who did go on to reoffend as low risk. The disparity's just, it's right there in the numbers.
But here's the really wild part. The algorithm wasn't explicitly told anyone's race. So how did this happen? It was trained on historical arrest data. And this just perfectly shows the problem. If that historical data already contains societal biases, like how some groups are arrested for certain crimes more often than others, the algorithm just learns that bias as a simple fact. It literally takes the biases of the past and encodes them like a blueprint for the future.
All right, let's switch gears to another place this is happening, getting a job. Big companies get thousands of resumes for just one position. So they're using AI to sift through the pile, hoping it'll be faster and, more objective.
Well, Amazon gave this a shot, and it did not go well. They trained their system on 10 years of their own hiring data. And as it turns out, that data was mostly from men. So what did the AI learn? It learned to prefer men. It even started penalizing resumes that included the word women's, like women's chess club captain. Yep, they had to shut the whole thing down.
Okay, case number 3, facial recognition. A huge study from MIT in 2018 put some big-name systems to the test. And the results? Big yikes. Basically, the tech worked great for white guys, but for women with darker skin, the error rate for just identifying their gender, it skyrocketed to almost 35%. 1 in 3 times, it got it wrong.
And look, this isn't just some abstract number in a lab. These errors have real devastating consequences. I want you to hear this quote from Robert Williams. He was arrested at his home in front of his wife and kids because of a bad facial recognition match. He said, "When I look at the picture of the guy, I just see a big black guy. I don't think he looks like me at all." This is the human cost, right? A glitch in the data, a bias in the code, and a real person's freedom is on the line.
This whole problem of biased data creating biased outcomes, it's not exactly new.
And a perfect way to see this in action is to look at the history of something we all probably use: translation apps.
So let's take a quick trip back in time. First up, back in the 60s, it was all rule-based. Actual human linguists wrote out all the grammar rules. Then in the 90s, we get statistical translation, which used computers to find patterns in huge collections of text. And that brings us to today, with the neural approach, which is pure machine learning on an unbelievable scale. You see the pattern, right? Less human rules, more and more data.
And these modern systems, these neural machine translation engines, wow, they're just incredibly powerful. They can create translations that sound supernatural by learning from basically all the text on the internet. But, and you know where this is going, it's only as good as the world it sees in that text.
And boom, here is a perfect example. Okay, so in a language like Turkish, there's one pronoun for he, she, and it. It's totally gender neutral. But when people typed a phrase into Google Translate, as you see on the left, the translation would automatically spit out gender stereotypes like he is an engineer and she is a nurse. Why? Because that's the pattern it learned from all the text online. Now, to be fair, as you can see on the right, Google did update this to offer both options, which is a step in the right direction.
So that's the problem. A pretty big one. The big question now is, what on earth do we do about it? Where do we go from here?
Well, there's no silver bullet, but people are trying things. One way is auditing, where companies actively test their AI for discriminatory patterns. Another idea gaining steam is a moratorium, basically pressing pause on using risky tech like facial recognition for law enforcement. And then there's just plain corporate responsibility, with some big companies like IBM actually deciding to get out of the general-purpose facial recognition game altogether.
And all of this leads us to one final, really tough question I want to leave you with. We all know humans can be biased, but now we've seen how algorithms can inherit those biases and sometimes make them even worse. So, which is worse? A biased human who might be inconsistent, maybe you even have a change of heart? Or a biased algorithm that carries out its flawed logic perfectly, systematically, millions of times a second, but which, maybe, just maybe, we could actually audit and fix? There's no easy answer, but it's a question we absolutely have to figure out as we decide how much of our future we're going to hand over to the code.